William sits down with Chris Wade, co-founder and CTO of Itential, and Craig Johnson, technical solutions architect at Forward Networks, on the roof of the Hyatt in sunny Tampa Bay for a spirited roundtable. In this conversation, the focus is practical and the conversation is raw. How is generative AI impacting network infrastructure? Why has network automation seen slow adoption in the enterprise? Is AI driving a more verticalized tech stack? And what is next for network infrastructure?
Welcome to another episode of the Cloud Gambit. Today, coming from beautiful Tampa, Florida, I have Chris Wade from Itential. You want to introduce yourself, Chris?
Yeah, thank you. My name's Chris Wade. I'm the CTO at Itential. We build network automation and orchestration software.
And I also have a Cloud Gambit alum, Craig Johnson, from six or seven episodes ago?
Yeah.
I can't remember. So you want to introduce yourself?
Absolutely. Craig Johnson, technical architect at Forward Networks, and I lead our cloud team. So we are a network digital twin for your multi-cloud network.
Awesome. So none of us are from Tampa.
Nope.
You're closer, and you are in Dallas.
Dallas. So 2.5 hours or so. So similar kind of weather. So yeah, not too bad.
Not too bad. So we were here for the USNUA. They call it FlowNug. Florida Nug.
Got it right here.
Show them the shirt. Yeah, it's great. Good shirt. So community event around network infrastructure, just all things networking. We had a blast last night and it was good. And we decided, hey, we'll record an episode here on the roof. So getting into some topics, generative AI.
Oh, no.
It's Craig's favorite topic in the world. You really can't walk into grandma's house anymore without having a discussion about generative AI, hearing about it everywhere. It's getting crammed into every product out there. It's also monopolizing the news cycle. And I know with new tech innovation, like when cloud hit the scene, like ZTNA, Zero Trust, serverless is a big one too. They just become polarizing and folks almost get like tunnel vision. But nothing compares to like the hype machine that we're seeing with generative AI. I'd say, how do you both feel about what is the actual value in the real life application at this point of generative AI in the domain of network infrastructure and automation?
So having lived through the SDN and OpenFlow days, this is a little deja vu for me. I think there is absolutely some value. The value I see is more on some of the co-pilots that I see out there. Instead of a generative AI to, solve your problems and do the configuration for you, I think there's a lot of value in things like helping you with, config completion, giving you config snippets and blocks, telling you maybe suggesting a config that you might need to do to solve a task. I'm a little more skeptical at this stage of the game of something of a full closed loop to actually suggest, run, config, validate the entire automation to you. I don't think we're quite at that level where we can remove humans there, but I do see a lot of value in Copilot starting out in the coding space and now moving a little more into the network automation infrastructure side.
Started off with an easy one, huh?
Go right for the throat.
Exactly. You bring up OpenFlow. I would compare it a lot to what we've been through with CLI. I think a lot of these first applications have really been built for humans. So whether it's augmentation and code development, prompt engineering is very human driven. You asked how it's going to apply to networking. I think we really need to think about machine interfaces. It's kind of a bummer for me as we automate and orchestrate the network. We're trying to remove that human tax from doing that, and to think that we're going to orchestrate prompts seems a little strange to me. It seems like it's very interesting, but I'm looking forward to the machine interface to these things. Copilot's so generic. I'm looking forward to the next couple weeks as we see very smart agents that actually know what they're doing, that we can ask smart questions to and get smart answers. So I think this first generation is very interesting. but maybe not as applicable like in the automation loop. It's more like an augmentation for humans as we get started.
Yeah, I totally agree, because really at the end of the day, it's about, especially as we've seen cloud adoption, like what are enterprises actually adopting? What are businesses willing to pay for? And right now, there's a lot of AI products out there, and from the looks of it, to me, they're still trying to figure things out. Like all this is there's so much exploratory stuff going on, and of course, you bring up automation and orchestration. Many organizations out there are just struggling to automate their networks. I think in a lot of cases there has been progress with like individual task-based automation. Like, hey, we need to add some VLANs, or we need to do these individual things. But in terms of like, and those are all low risk, extremely low risk changes usually. What is the right way to think about the separation of automation and orchestration, and sort of fitting those in like in the enterprise space?
So I typically like to think about our cloud friends and how, I think in a more controlled environment, we've been able to make more progress. So automation is very domain specific from my perspective. How we automate a firewall, or how do we automate a data center versus how we automate cloud, is quite different. When we think about orchestrating things, the typical pattern from an infrastructure as code perspective is really pipeline driven. So as people think about like, what do I put in my Terraform plan versus what I put in my pipeline, it's kind of task-based execution that you don't want to touch as much, and then some of the fallout logic, testing logic, end-to-end logic we tend to put in that orchestration layer. So I think as people think about tying multiple domains together, typically that task-based automation you're talking about gets very convoluted, a lot of business logic, and then we think about our script heritage where fork and modify. So trying to keep that separation allows us to keep our automation very reusable. You can share, you can use for multiple use cases. So it's really that separation, I think, of domain automation with kind of orchestration, tying those together.
I guess to sort of add on that, so I remember this very specifically because it was a pretty rough project, but I worked on a big automation initiative with like the business had a few different network teams. So we had actually a separate team for like campus. We had a separate team for colos. We sort of had a separate team for cloud at the time.
Sure.
And we had this, it was when automation was super hot, and we were trying to find ways to, I guess, bring our change management into the future. We were still like really heavily ITIL based, and we had this thing. I think the name was like, we named it like Greenlight API, and then it just got renamed to Greenlight. So basically it was things that we would choose, like a whole process. And some of it was like automating prefix lists and things in a colo, or route maps, changing route advertisements to like a specific cloud provider, but then building like net new things within the cloud. So we put all these things in a pipeline, worked with change management, and that became a process. But then even then, after we started doing this, they wanted us to represent these things on change advisory boards, and we couldn't, like, there wasn't ever a case, even with like net new stuff, that we could just run the pipeline, have somebody hit the rubber stamp and then go. This change advisory board, this traditional way of managing changes to really mitigate risk, and I totally understand that, it's a really hard thing to get away from. Do you have any thoughts on how culture, how change management, how these things, where they're at and how they can kind of come into the future?
Yeah, I would say, I think the added technology easy, people hard kind of comes in here. I think that some of the struggles you speak about with automation come down to, we actually have to change how we operate. We have to change the operations. And if we try to automate the way human processes work, we end up with a lot of kind of awkward things. Some of the first use cases we always see with automation is we automate the existing process. And as soon as you see it automated with computers or machines, you look at it and say, that makes no sense. So we actually have to modify how we do that. And I think the question is we still have to orchestrate humans. I think CCBs is human orchestration. We're not going to get rid of that. But I think the key is to separate which things are human orchestration and which things can be machine orchestration, and really focus on the use cases and the aspects of automation and orchestration that can be accomplished full end to end. And I think those examples where you kind of run into the wall, people start to say, well, we can't automate other things. So I think use case choice is often overlooked, and changing how we operate versus automating the way we work today.
I guess I kind of take a little bit of a different tactic with that, because I look at some of our partners in the other side of the IT world, and I think by the nature of networking itself, we lack the validation. You know, how often do we run something similar to like a unit test on any sort of network automation or change? It's really not possible in a lot of cases. And I think that's where a lot of the skittishness where people comes in. And I think we need to have something like that, some way to validate so that you can give that change advisory board the surety, yes, we've tested this change, and not simply, yes, I know this config will apply correctly, but I know that it will actually have the impact that I expected it to. And I think that's where, you know, we've all been burned way too many times on that. So even when you do that very domain specific, where yes, I can push this config change with an Ansible or something, I can make sure the config complies correctly, it's still far too complicated with all the protocol soup that we have out there to really make sure that I know what the impact of that change is. And until we have a way to create that level of validation, I don't think that will change, at least among the entire, you know, business logic.
That's a good segue. You know, audit just the sheer idea of, hey, we want to automate to standardize and to make things faster. It's not enough. You need a way to validate if changes that you're going to execute are going to impact the larger environment, larger infrastructure. And now enterprises, you know, they're not just on premises; they've got infrastructure kind of everywhere, multiple clouds. Just no longer the days where it's our four walls of our data center and we own everything from top to bottom. So I would say, how is, you know, Forward Networks is, you know, leading in the sort of the digital twin space. Y'all do some really awesome work. How are you viewing the future of this problem? Like, do the tooling and everything need to change to support the generative AI stuff? Is that still getting figured out? Or, you know, does it not really impact the value proposition of a digital twin, and you just kind of hook it into what's happening right now?
So I think to your point on the machine interfaces, I think that's getting better among the vendors. And I think we are seeing the ability to have that level of automation. So you're not having to do screen scraping and CLI. So I think we're getting a little better on being able to model what those devices do. And as we look inside the cloud, yes, because I can set up parallel infrastructures, it's easier to, you know, to look in that perspective. So I don't have to, you know, modify my current infrastructure. I think you need to have some level of, you know, modeling and parallelization of your network. And vendors are getting better about providing, you know, tools and labs to do that. Obviously, you'll never get down to exactly what an ASIC will do. But yeah, I still think you're going to need some sort of parallel infrastructure that you can run those unit tests, run those pre and post flight checks are to make sure that, you know, not just that I applied the config correctly, but make sure my intent is correctly. So whether it is, you know, Forward Networks or any other type of twin out there, I think you have to have something like that. And that's really, to me, that's the enabler of a cultural change, because then I can prove in one way or the other that yes, this change had the impact that I wanted it to, or it didn't. So I don't exit the change with a broken network. I mean, it's far too complex these days to, you think you've made a change correctly, you've automated, you've pushed it out, but it's not until some weird app on Monday morning that you had no idea doesn't work. And because nobody can check every application on the network, and nobody can be on the call during a change at night to check it all as well.
Just to add one thing there. I mean, I like to think we're in the trust and confidence business sometimes. And I just keep going back to, you know, when we're talking about this, you're talking about, you know, unit tests. These are all machine interfaces, right? So I think historically we've had, you know, a lot of blinky lights and other human focused network management concepts. And if we're going to get to the point where we can run things without human in the loop, you know, I think we have to think machine first and change how we operate.
Yeah, totally agree with that. And so roles and responsibilities. So there's a lot that the vendor community can do. I know that all three of us work for, Forward Networks, Itential, Alkira. We're sort of almost in the integration play where, no enterprise I've ever worked for or ever seen is going to use a single vendor product for all security or all network. And with the progress of like APIs, the progress of software, it's a lot easier to integrate, as we all know, with other vendors nowadays with APIs. We're kind of speaking the same language most of the time, which is really awesome. It's not hey, I need to file a ticket or a feature request with this vendor that's been around that like maybe manages boxes, and it just disappeared into the product management suite, and you just don't hear anything for like a year. So I guess the question is there something more that vendors can do to make this transition better for enterprise? And also, like, what can enterprises do as far as their thought process and adoption to make things more smooth, with these changes?
A lot to unpack in that question. So I would say I find it unacceptable for modern software vendors to not be able to interoperate and require like a huge army of integrators to make that happen. But it is a little different in the sense that we have standard technologies for integration, right? So we can talk about REST APIs. We can talk about some of the gRPC stuff going on at the lower layers, NetConf and other things. But if you look at like hyperscaler documentation and APIs, like I can read the docs and figure out what to do. A lot of times, we do integration amongst the three of us, also industry wide. And I often have to ask, what APIs do I do in what order to accomplish the outcome I'm looking for? So I think we all like to post our APIs. Some of us hide them behind, NDAs and other things. I wish everybody just put it on the internet. But I really think the documentation and understanding how to use the APIs is the key bit. So, as far as enterprises go, I would find it unacceptable for vendors not to like amongst themselves figure that stuff out. I think we've reached a technology point where that is table stakes. But as far as how to use it more, I think we have to collectively work on making it easier for people to know what and how to use our APIs. And I think documentation is number 1, 2, and 3.
Totally agree.
I do sympathize with the vendors a little bit because it's not easy. If you haven't architected an API first application, it's hard to bolt it on afterwards. I mean, we've all probably worked with APIs that are simply wrappers around CLI commands and things like that. So where you can tell they've bolted it on afterwards. And if you don't have a data model that's built from the beginning, if you don't have a good API first application, it's hard to retrofit. That being said, I totally agree on, when you paywall your APIs and you make it difficult, that just makes everything difficult for everyone else. And I understand that's a demand driven, that's a product driven thing, but I do think that is one place vendors can absolutely, even though I understand they don't want to divulge potentially competitive info, things like that, that is absolutely something that everyone should demand from every one of their enterprise vendors. If it's not API first, and if you don't have an example of your customers, not even consuming your fancy GUI that I'm sure you're very proud of, that, yeah, you should absolutely demand that of your vendors.
Yeah, I agree. And I think I think in the very early stages of a startup, I can see them wanting to keep things walled off and everything. But once things are real, once the rubber hits the road and things are happening, why isn't it out there? It's actually going to help you. It's actually going to help you with marketing and sales to have it out there. It's actually an advantage to you to make those things public, in my opinion.
I would say my sympathy is at an all-time low on that topic. But if I could say something positive about it, I think the networking layer has stabilized, which I think is the most positive outcome that's happened over the past maybe 12, 24 months. And I think with that stability, people can start thinking about what I'm going to build on top of it. If I'm adding a new SD-WAN, if I'm adding a new middle mile, if I'm adding a new colo, if I'm doing multi-cloud, if I'm putting these pieces of infrastructure in place, I don't know what's changing, right? So I'm constantly thinking I'm adding maybe zero trust on top of my firewalls. I have all these things changing. I don't understand what's connected to what. So my level of automation maybe isn't there. But with modern infrastructure and with stability in the networking, I really think the focus on building some operational platforms is a lot of focus from people I speak with.
Yeah, I know you've brought up the hyperscalers a few times, and I know that some of the the folks that have been in networking at large, like some of the pioneers, some of the heavy hitters, I would say there's a lot of reluctance to for a long time that okay, you can actually automate a network end to end. Oh, it's too complicated. It's this or it's that. Everything is a snowflake, but the hyperscalers did it, and they did it pretty daggone good. I would say that AWS, Azure, GCP, Oracle, they've got a good thing going on. Is there any merit to learning from those bigger companies, even though, I mean, under the hood, it's not like you have a total insight into exactly how they execute and do everything, but you kind of get the gist of, we know the technologies, we know, the options, and, it's not like TCP, IP, BGP, and all these things has changed, drastically in the last 20, 30, years. So any thoughts there? Can we learn from the cloud and not be scared of it?
I think we learn more from the people using the cloud. I think most enterprises said they wanted data centers to run like public cloud. I think there is some merit there. But what I'm always impressed with is just the scale and usability that's driven. So I like to look at how people leverage the cloud for scale and say, how can we recreate that scale? I think, in the networking world, we always love abstractions. We love data models. That is from our historical past of pain of multi-vendor networks and vendors not having standards on top. So we've tried to apply that, I think, that thought process in the cloud domain. And, right or wrong, there's not 27 public cloud vendors that most of us use, like we used to with vendor infrastructure, firewalls, load balancers, route switch, everything, blah, blah, blah. So I think trying to build abstractions, trying to make them abstracted so I can move payloads around, what we used to hear like 5 years ago type of stuff. But they've continued to build more aggressive automation and operational excellence, which allows them to scale. And I think looking at how we operate the cloud and saying, how can I apply those principles to our infrastructure? And then, Craig, what you were talking about earlier with some of the nuances of brownfield and uniqueness in the network and trying to build unit tests around that, we have to really evaluate the time, effort, energy, value prop in that versus some of the mass scale value benefit versus the kind of bespoke uniqueness that we like to kind of project a lot of times.
So I have a slightly different take. I think we've lost something in abstracting everything that we've done from the network. Like if I look at what the cloud providers do, they of course have plenty of abstraction layers, but they get huge amounts of data from all of their devices, all the way down to the ASIC level. And they demand that from their vendors. They don't just say, give me your CLI. They want access to data that comes from every port, everything that happens. And I think we've somehow sacrificed getting the data that we need from the network, from the flows, from how everything's going into, lots of different abstracted protocols and abstract APIs, which is great for automating and pushing it. But at the same time, you lose something in that level of validation when you don't have that data and you're trusting, everything that is happening from, a 40 teraflop ASIC to simply 5 lines of CLI. You lose a lot of the context with it. So you're left to trust whatever the vendor says is true. And I know the hyperscalers definitely don't do that. They go all the way down to the metal. So I think there's something that we lost there that I think we need to get back to get that level of confidence in the network.
That's a good point. And honestly, if things don't meet the status quo or the demand, I would say, or the innovation that hyperscalers want to see, they roll their own. They'll build their own. They'll, work their own supply chain. They will do it all themselves and bring it in-house. And they have the deep pockets to do that, of course. So I think, those are some really good thoughts there. So we're in 2024 now, and every vendor is also, every network vendor specifically is also an AI company, and is also a network as a service company. Mm-hmm. We kind of discussed this last night. Like, what does network as a service even mean anymore? So what are you both seeing from like network vendors? Is they attempt to actually incorporate like AI, machine learning, artificial intelligence, or the smart agents, you brought that up earlier. Are they going to take over? Or is it going to start more practical, like maybe using LLMs to scrape documentation, generate config snippets, or, starting off small and slowly grow? What are you all seeing there? And actually, as a follow up to that, Cisco Live's coming up. Are you both going?
Absolutely.
You going?
Yeah, I'll be there.
Awesome. So I'm sure there's going to be some absolutely epic, amazing announcements in the keynote.
Of course.
So I'd love to hear your all's thoughts on those things.
So I think I would be, I guess I will be shocked when Cisco doesn't announce some smart agent next week. But it's going to be interesting to see how this kind of plays out, because I can't imagine. I mean, Cisco has every TAC case, every Cisco config. Like, I can't imagine anybody on the planet for Cisco equipment to build a better intelligent agent. It would be awesome in my flows and my unit testing. If I get an error message, it'd be nice to ask the agent, how does this happen? Versus me writing 84,000 unit tests. It'd be nice to have, I write my unit tests that are pertaining to my business, but then I get to ask some unit tests against a smart agent that knows generic, Cisco equipment. But I think where it ends up is it verticalizes the stack even more, because I think these AI agents are going to be very specific to the vendors. I don't think Cisco's not going to train Juniper and Arista switches, right? So what that means is, we forever have tried to abstract the device level, right? So this operational level, and I think AI is actually going to force it up. With controllers, we've had kind of this operational layer put on top of this infrastructure. The original intent of controllers was to be domain specific and vendor agnostic. That kind of went away, I don't know, 2016 or 17. So I think AI is only going to accelerate that. So we have to think about how do we live in a world where there's more verticalization in these technology domains. And we might be integrating at a slightly higher level, unless you're just going to scrape the controllers and scrape the AI and all that operational intelligence off and just deal with the bare metal, as you were talking about, and build it up from there. But I think the average enterprise would get great benefit. I mean, we've seen, I think, great benefit from controllers, mass pushes, single point of software control, lots of benefits to controls. I think my opinion is AI is only going to accelerate that.
Yeah, I think I tend to agree. And I think it gets, you talk about Cisco, and, if I say I run a Cisco shop, which one of 5 different Cisco operating systems do I run, and what exactly does that mean? So I think even when you talk about even a single vendor, you don't get out of this problem as well. And I think I tend to agree. You need to push this up. And does that mean there will be LLMs on top of LLMs to do this? Very, very likely you'll see something like that. And I think in the last probably 12 to 24 months, we have seen the, help me generate this config, or validate this config does what I think it's doing. But I think the next level is definitely those kind of agents to maybe proactively tell me, hey, I see these log messages being hit, or I see these counters being hit. Here's what that kind of means, and give you some level of proactivity to it. So I'm hoping there will be some kind of announcements out there. I would be surprised if there's not. But yeah, I think the next step is going to be not just, what does it do for ACI, or what does it do for Viptela? How do we abstract that across vendors? Because like I said, even if you say you run one vendor, that one vendor has 5 different operating systems.
Maybe turn the tables. I'm not CCIE. I don't know if either of you are. I didn't look at your bios.
Craig has like 1,000 of them.
1,000
like all of them. He has all the CC. He's like, a bajillion CCIEs over there.
So if I could, maybe a question. Something I think about is, when you talk about LLMs, I think the next version of AI is hopefully beyond that. Hopefully we have some machine interfaces and some cool stuff. But, we're talking about, the obvious ChatGPTs, scoring 1580s on SATs, think about my kids taking those types of things. So what would the CCIEs on the street feel about a smart agent that's able to produce some of this content that's between people's ears? I'm just very, very interested in what how people are going to think about that. Is it augmentation? Will Cisco slow roll it because there's a concern about that? How does that work?
So before we get to the real answer with the expert over there, my take on that is most of the CCIEs I've hired and worked with over the years, and I never got the lab, so I got the written at some point, and then I actually had kids, and that test is a sacrifice beyond measure with your life. But I think CCIEs, most of the ones that I've worked with, it's very deep. They do network design, network engineering, network architecture at a very fundamental level. like many layers deeper. So like they're the real architects of like some of the biggest networks. And it's almost like, you hire a general consultant to come in and do your bathroom that does like a few different designs, and they don't really go that deep. They can't do really custom tile work. They're not going to do custom fixtures or actually build anything. They're going to buy everything, slam it in there, and give you the bill. CCIEs are like the really in-depth contractors that come in, custom tile, custom wall, custom everything. And a lot of times there are a lot of CCIEs out there, I take it, that are into automation and have learned to code and stuff. But we're all human. There's only so much we can really go so deep on. And, CCIEs are definitely deeper in the network design stuff. Craig?
Yeah, it definitely goes to a very deep level. And I, like you mentioned, I have far too many over the years. But the idea that I think that is the most relevant here is even the best CCIE, doesn't deal with a 300,000 line firewall config any better than anybody else does. So yes, you may understand what's going on, and that's where I think those AI agents can help. How just because I know exactly what every line or theoretically what all the rules will do, that's still a lot of data to parse and process, and it's really just too much for any human to know. Even the best CCIE in the world, once you get above maybe 100 device network, can't do it on their own. There's just too many variables at play, even if you understand it. And it's very helpful in the troubleshooting space. Now, I do, for better or for worse, I do think that is where a lot of the AI agents will really help, because the forensic analysis that you have to do when a network's broken, it takes that level of CCIE knowledge to know exactly how everything is forwarding, because now that it's not working, you know exactly what you need to fix. I think that's going to be a huge application that we're going to be seeing, and those kind of early warning analysis on there. Not everyone can see, some error message on some weird switch somewhere, and then 9 hours later, that causes my entire data center to go down because it causes a loop or something. Those kind of early warning systems, I think, that a NOC would see it, but doesn't know what that means. An AI agent would absolutely be able to start to interpret that in conjunction with everything that the vendor has, assuming that they open those kind of things up and know that, oh yeah, when you see this message, yeah, we've seen 20 other attack cases that are P1 down issues. So absolutely, I think so.
I have another thought here. That's some really good points. One thing I see too, and I'm a product of this, unfortunately. So I used to be full-time network engineer. I started out my first network project actually was decommissioning CSS load balancers when I was a network engineer a long time ago. I used to eat, breathe, live Cisco, networking, TCP/IP, BGP all the time. So the more abstraction that gets injected with network products over time, the less deep that you have to go to fix things, to build things, and to do things on an enterprise network. So what I'm seeing a lot of is network engineers are being asked to do more. So a lot of them have almost been forced into becoming generalists in a lot of ways, because you have to keep the lights on. You got to keep the network running, and there's a lot of cross adjacency stuff. Now, I wouldn't say that I'm a complete generalist. I still write code every day. I've still got a Kubernetes cluster running in my basement. I still lab BGP and stuff, but I do it a lot less. And the less you do that stuff, it's not like riding a bike. You don't use OSPF. Like, I haven't touched OSPF in a long time, and I had to set up. I did some OSPF, whatever the FRR version is.
Oh yeah.
And like LibreSwan IPsec the other day, we set up some stuff with like Container Lab, and getting back. And I'm just slower. Like, it takes a lot longer to spin this stuff up. But I still understand the fundamental mechanics, but just interoperating everything is not an easy task when you're not day in and day out.
Yeah, that's absolutely true. I'm very much the same way. And I think that's really the hard part about networking, is nothing ever goes away. Nothing ever gets retired. I think in software development, I think in all other IT spheres, there are trends, and then there are supplants, and then, okay, nobody uses Perl anymore. Nobody uses old Pro. We move away. we still use spanning tree. We still use everything that I started in networking in late 90s. Everything is still there. That's gone. No, we've added a whole bunch of layers and abstractions on top of that. And, yes, I may be talking SRv6 today, but everything under there is still all the same. And I think that's really hard for people to get into. Like, when I took my CCIE back in 2001, sure, it was BGP, OSPF, and all that stuff was still there. Now, if I take something similar, I have to add a whole bunch of things on top of that. Plus, I still have to know all that stuff below that. So it makes it really difficult for anyone to get into this, to, at this level, to not be a generalist with it, because, yeah, you're having to keep up with that old technology.
Yeah.
Just one thing to add, the complexity is almost going in the opposite direction. When we were integrating boxes inside the Cisco router, whatever was inside was inside. So now we're cracking that open. We're doing Linux networking. We're doing service meshes. We're doing container networking. So it's almost like, as networking, the complexity was the raw volume. And now it's like going the opposite direction. Maybe some chemistry reference or something. But now we're breaking it apart, and the complexity is almost going the opposite direction. So, the positive part is that protocol-wise and otherwise, we haven't had a ton of new stuff. Most of the innovation, I would say, over the last 8 years was, macro management, controller, abstraction. And now it's going the opposite direction. I think the complexity on compute is now making its way into networking, and the variety of skills it takes to understand the full stack. To your point, warps your brain a little bit as you start doing container lab, and then you're thinking about macro WAN networks, and then it all tied together. So, yeah, at the end of the day, the provocative questions were not about any sort of replacement of ideas or concepts. It's really about augmentation and the need for all of this knowledge for us to have a grasp of what's going on. And I don't see an end to the complexity factor. I do see an end to kind of the raw network innovation that's been happening.
Yeah, agreed. You're right. Like, I remember I had to troubleshoot this issue where there was a problem between a data center that we had and a Kubernetes cluster in a cloud. And all the thing, like, it's not as simple as following a packet through some network devices, layer 2 frames, this interface, out that interface, redistributed into that routing protocol, like the whole packet walk thing. Like, no, I'm going over this circuit into this environment, into this routing table. Okay, up to the cloud, trying to figure out what the heck a cloud route table, figuring that out. And then, okay, going up into the service mesh land, which is like completely different world, like completely new skills. It's just a different place.
As much as we wanted V6 end to end,
NAT everything all the time.
The application teams are like, I care about my Kubernetes pod, and I don't need to worry about the rest of the world. So I'm going to make this super simple.
Yeah.
Like, that's, we don't...
Cleaning up the app team's garbage.
At the end of the day, we're here to support apps and humans, right? So unfortunately or fortunately, sometimes these app teams drive the bus, and they want their world simple. And to your point kind of earlier, is that complexity kind of gets pushed to a spot. The complexity exists. We got to deal with it at the right place.
Well, and I think,
I can see that.
There we go.
Okay.
No.
Thought you were going to start dancing.
I think for me, it's why I enjoy working in the cloud so much, because I know the cloud providers under the hood, they run all the same MPLS and SR networks and PE and P routers. They do all of that stuff. But to my interface, the most complicated thing I have to do is BGP, and only in a very small amount. Like, it's always the dirty secret I tell people. It's like, it's really quite simple. Everything is static routed for the most part. There's a
like we discussed last night.
There's a little
static
bit,
everything.
Yeah. So there's a little bit of there, but it makes it very easy for it to work. And so I think, to your point, obviously this complexity can be solved, because they run sometimes more complex networks than most enterprises do. They write their own NOSes in some cases. They write their own protocols to mesh everything together and don't just use stock BGP. So obviously it can be done. I think maybe to your earlier point, perhaps the vendors just don't provide the right level of interfaces to abstract that just yet.
Yeah, just one use case that I think is always interesting is OpenConfig. I'm done. I'm just throwing out lots of stuff here. But who drove that, right? It was AT&T and the hyperscalers, right? So what they did was they said, these are the products we're going to support. We're only going to support these APIs, and you have to comply.
There's a lot of smarts behind doing that. You set yourself up for success.
Exactly. And I think that's kind of to your underlying point is they said, we're going to scale, we're going to simplify. And that was the starting point, right? And then if you say, hey, I want this API call because I have this esoteric requirement, they say, no.
Yeah.
I have to wonder.
That's a good point.
You say open config. Why hasn't that translated down to the rest of the enterprises? Like, of course, the hyperscalers, they got it for their use cases, but we don't see open config in every protocol and every configuration out there. It's only to that very small set. What's prevented that from something that the rest of the world needs, and why hasn't it been given? Just your thoughts.
Now it's super loaded. I brought it up, so I guess I get an answer. I mean, at the end of the day, it was a way to simplify operations, right? And they knew what products they wanted to offer. And a lot of times we're wiring up stuff for applications we don't know that are coming, right? So we're trying to what will the requirements be in the future? They come at it from a product down. We're going to offer this product in the marketplace. What features do I need? And then they go to the vendors and say, you're going to support this. Now, did every vendor support open config the right way, or did they write a shim layer on top of their existing, Yang models? That's vendor by vendor specific. Kind of not the point, but they say no more than they say yes. If you go to the open config sessions, they are very opinionated in what they want to support. And when you say in the enterprise, people that are making the requirements of those teams, they can't satisfy all those requirements with the limited use of open config. So I don't think every enterprise can get to the point where they support open config, but at the end of the day, we need to understand what our customers want. We need to understand what the application teams want, and then build the simplified infrastructure to support that. Not that brownfield's going to go away, not that spanning tree is going to be eliminated, but if we start thinking about where we're going, if we got to push the boat forward, it's a little bit top down. I think when you brought up earlier, what do we learn from the hyperscalers? I think that operational mindset is very interesting to me. I don't think the average enterprise is going to write an OS. I don't think they're going to do ASIC inspection. Whether they buy tools that do that for them, that's great. But I think that operational behavior, the application first, product centric mindset, is very, very interesting. The whole platform engineering era, I think that's the core part, is the product mindset and delivering to those end users what they're looking for. And if you can back end to support open config, great. I just use it as an example. It's like a little bit of lightning rod for a lot of people, but it's like, why won't they bend to my use case? And then at that case, that's how some of these NASs got so bloated, because of every feature request that they stuffed in there.
That's such a good point. I mean, if you think about back in the earlier days of AWS and EC2 VPC, virtual private cloud, if they would have said, okay, we're going to support everything a customer asks for. Okay, we're going to hairpin traffic with every VPC now. We're going to be able to insert this here or do this there. And you're taking all these things, their scale would not be what it is today.
We do love our nerd knobs.
Yeah, exactly. And they could have come out with Transit Gateway a long time ago, right? They held their ground, and they were trying to understand the right product and the right fit for the vast majority of enterprises. And now what do? We build our infrastructure around those constraints. We build, and that the byproduct of that is the simplification. That byproduct of that is the operational scale and some of the other stuff we talked about.
Well, and that opens the door. So like AWS is like building with Legos. There's a lot. The sky's the limit for the things that you could potentially build on cloud and scale across the planet. And having that sort of architecture and those principles from a hyperscaler enables vendors like Alkira to build really intelligent, awesome things on it, that scale across that cloud provider to other cloud providers and such. So it's also a good thing, because it provides you the tools to build really unique things that really itch the scratch and fill in some of these gaps for larger companies out there.
Yeah, I think that's correct. I do think something kind of gets lost there. I mean, I hate to use the lock-in word, but if I have a Cisco router today and I'm upset with them, swapping it with a Juniper is whatever, who cares? So it does wind up being, I am looking at a solution. Now, granted, there's not a whole lot of competing solutions, so that's not an issue. So I can see why that gives people pause. And that's more of a traditional model. People thinking that they don't want to be locked in, and there really isn't such of a lock in. There's none of that level of vendor pricing that you're going to get from AWS. It's whatever you're going to scale up to. So I think that's why people are clamoring for these kind of abstraction layers on top of the clouds. Do I think it's the greatest idea? No, I think you buy yourself, you get yourself the worst of both worlds. You get the extra complexity of doing something totally different the way Azure does it, and you don't get any pricing support for that as well.
Yeah, good point. And I know both of you actually have to catch a flight. I'm going to ask one more question that I have to get out. So I remember one time I was working on a large-scale automation project, and things, it was cross-team, cross-discipline. And we were just having issues because each team was using their own tools. They're speaking their own language. Not everybody understood Git and software delivery, some of the methodologies. And I remember it was one of the times that I was giving excuses to higher ups. I was like an excuse box for a little while, and they were like, stop. The outcome I want is from end to end. I want this whole thing to be automated. I don't care what the problems are with individual teams. Figure out a way to make this cohesive across teams. And, that is the outcome. And it's much easier said than done, obviously. Is there, how can we make, when you think of the whole infrastructure domain of networking, you have, cloud, you have network security, you have wide area network, the campus and application networking. How do we bridge the gap between all these teams so we can get there? Just any thoughts there?
Well, not to be self-serving, but the idea is everyone does need to speak the same language, and everyone has their own domain of it, and everyone has their own particular config quirks and interfaces. But networking is remarkably the same no matter what. Packet goes in, you change some headers, it goes out a particular port. So if you can get everyone to speak the same language, whether you're a security team, a cloud team, a network team, and if you can, I think I've used the word abstract way too many times this session, but if you can put a way to have that sort of interface so that everyone is at least seeing the end-to-end, like you mentioned, the intent of it, what exactly does it work end-to-end? I don't care about the vendors along the way. I think either you build your own type of digital twin, in your lab environment, or you rely on something, commercially or open source out there, not to be self-serving on that, but I think there is that to me, that's really the key to it, because I don't think there's going to be any less vendors coming out. Some will come and some will go away, and economics. I've noticed the economics only have to change slightly for businesses to radically flip around. When compute gets a little cheaper, when storage gets a little cheaper, when cloud gets a little cheaper, there are vast shifts on there. So no matter the repatriation is the word right now. Next year it may be something totally different. We may go back to distributed computing or something like that. So none of that will ever change as the economics change. But everyone needs to be able to speak the same language.
So the words you used to have these people work together were a lot of software words, right? So, we build software every day. Database team and the web server team and the message bus team don't need to necessarily truly understand what each other's doing, right? So the firewall team and the data center team, they have to be excellent in their domain, right? But we have to have interfaces so we know how to work with each other, right? And that means both technical interfaces and operational interfaces. So I think, how much infrastructure is code, how much software development principles are the answer here versus the balance. We do want the most people to participate in automation, and that sometimes does the barrier of some of these software skills is maybe a bridge too far in some organizations. But I do think, we talked about learning from hyperscalers. I think learning from, building, we talk about millions of lines of config, millions of lines of code, and how do we all participate in that in a very controlled way, so that when we ship product, we can manage the level of defects. So I still think maybe a little less Git and a little less pipelines and more maybe SDLC type of concepts. But these teams need to build functional areas of excellence. We can learn from how Linux was developed. Each area needs to be excellent, and you need to expose your interfaces in a meaningful way so you can tie them together. Too many times there's pockets of nothing, and we try to peanut butter it with, I know this tool or I know this concept, and I'm going to apply that across the board so I can get to end. Might not be the right tool for each domain, we're not going to solve the message bus with a database strategy. It's like I'm trying to apply software principles, but I think that's ultimately the thought process that gets us there. And trying to shove everything in one system or use one tool it's gonna be ultimately a problem, as you brought up at the beginning.
Great points, both of you. Hey, look, this has been fun. Thank you for joining me on this beautiful roof.
Thanks for scheduling the weather.
Yeah, I'm on that. So can you have any social, anybody can follow you on? I can include it in the notes.
Yeah, LinkedIn.
Yep, you can find me LinkedIn or at Captain Packet on X/Twitter.
All right, I will include those in the show notes. Thank you, gentlemen, and good luck getting to your flight on time.